Live from New York, it's Ask an Engineer.
Hey everybody, and welcome to Ask Engineer. It's me, Lady Ada, the engineer. With me, Mr. Lady Ada on camera control, keeping it goth, broadcasting live from downtown Manhattan. That's also where the Adafruit headquarters are. That's where we do all of our kitting and our coding and our videoing. And you saw some manufacturing videos and all the electronic goodies. That's where they ship from. So right now it's asleep, so we're just broadcasting live. This show, we're going to be here for another like 45-ish minutes.
Yes.
Or so. We're going to try to speed around a little bit, but still get to all the new products, codes, discounts, videos. It's not out yet, and more. What's on tonight's show, Mr. Lady Ada?
On tonight's show, the code is BellCam. You'll figure out why when we get new products, but 10% off in Adafruit Store all the way up to 11:59 p.m. Eastern Time tonight. Go over some live shows, some of the stuff that we do. We have some main New York City factory footage. We've got some open source hardware news. We've got some 3D printing. We have Ion MPI this week. It is ISSI, brought to you by DigiKey. Thanks, DigiKey. We got top secret. We got new products. We're gonna answer your questions. Put them up in Discord. People are already putting them there. We save them, then we answer them.
Yeah, we'll do that at the end.
Adafruit.it/Discord. All that and more on, you guessed it, Ask an Engineer. Whoops. That
Ha!
was a show and tell. Ask an Engineer.
It's black and white logos, isn't it?
There we go.
Yeah.
All right. So,
It's live, by the
yeah.
way.
Yeah, this is live. You
Not
go.
live.
BuildCamp is the code. We have some free stuff that
Yeah.
you can put in your cart. Just a little bit of a heads up. We'll probably not have free stuff for international orders just because free stuff doesn't work well with customs and paperwork and all this stuff.
That's
And some countries are just like, hey, you can't send free stuff anymore. Not a big deal. There's not a lot, but we're just like, well, let's just make it easier. So domestic orders only. We'll get the word out about that when we change it. But just heads up, that is coming.
FYI.
For now, what do you
Yep, you get some free stuff, $99 or more. You get a beautiful PCB coaster with some bumpers to keep your drink off your desk with a lovely Adafruit logo built in. 149 or more, you'll get an RP2040 based microcontroller board with memory and semi-QT and buttons and NeoPixel. A great little microcontroller board to get started with Arduino or CircuitPython or MicroPython. 199 or more, we have UPS ground shipping in the continental US. And we still got our favorite round circuit Playground Express being given away if you order 299 or more. Um, it's got LEDs and buttons and switches, and it can run a whole bunch of different codes. So it's a great way to get started with electronics and programming without any tools required at all.
All right. We do a bunch of live shows. And we just wrapped up show and tell. Do check it out. We had Brent and Liz and Jepler and JP and DJ Devon. Bunch of cool projects. On Sundays, we do From the Desk of Lady Ada, where we show exactly.
They did like 8051 stuff.
Yeah.
What am I working on? We'll see
Exactly.
live.
Yeah, exactly what's on our desk.
Hot.
So we do the Great Search. That's when you can use the powers of Lamora's decades of finding things on digikey.com and help you. On Tuesdays, we do JP's product pick of the week. We have a highlight. Let's play it.
The UPDI programmer and the high voltage UPDI programmer. USB serial programmers, which you can use with your ATtiny chips. 3-pin JST SH cable that it comes with. That is going into the power on my little ATtiny 1616. I've got ground, and then I have the data pin going to the UPDI pin. Got a bunch of these little LED noodles, little nudes plugged into there as well. When I plug in the UPDI friend there, and now if you look in my Arduino session, when I hit upload using programmer, you're going to see it is going to very quickly make the connection, upload, send the code, and boom, now I have all of these 4 pins doing PWM stuff. Unplug the UPDI friend. Now I can battery power this. UPDI friend doesn't need to be plugged in anymore. UPDI friend and UPDI high voltage friend for programming your ATtiny chips.
Okay, and JP's workshop is tomorrow, and then on Friday, deep dive with Scott or Tim. All right, let's do some Python on hardware news. This is from the Adafruit Daily newsletter, adafruitdaily.com. We send it to you every single week. This is Python on hardware. Lady Ada, you wanted to talk about, in addition to all the, go check out all the projects and everything, but in addition to the projects, the updates, the Python hardware. You want to talk about the automated hardware testing using PyTest this week.
Yeah,
What is this?
cool.
Why is this cool?
Oh, where are we? I feel a long day.
I got a lot lined up here too.
Yeah, it's I have to look into it because it's like it was in the newsletter. I'm like, oh, I bookmarked it for later perusal because as we talked about in the show and tell, for Whippersnapper and Adafruit.io, we're starting to use the sort of mock Blinka to test the V2 of our Whippersnapper API and also like verify the data is being sent correctly. And we don't want to use real hardware because we want to be able to run stuff in continuous integration. But maybe we do want to sometimes run it on hardware, maybe both, either way. So what I thought was neat was Goliath, who does hardware with CircuitPython and machine learning and IoT. They like have their own. I'm assuming that they worked on this or they have a tutorial on how to use PyTest. And I was like, oh, this is perfect because what we want to do is once we start mocking out all the hardware interfaces for this like Blinka system for the fake hardware on Python, then we want to have like a way to quickly verify that when we add new systems to the protocol or like when we change the backend, we want to quickly be able to run everything and make sure that like the regression still works, like nothing has changed. Instead of waiting for customers to find out, which is like kind of sad for the customer. Like they'll tell us and we'll fix it, but it'd be better if we caught it while we're writing the code. So I'm going to check this out because we might be able to either run this on a Raspberry Pi with hardware or run it on GitHub Actions as we write the Blinka mock code, and it will like maybe even test it against like Whippersnapper. Like we might have like a fake Whippersnapper account that we have the GitHub's actions like talk to, and then we can use REST to query what data got sent, and like so it'll be like a nice round trip test.
Cool.
Basically, it's like how to test hardware without testing hardware, but testing the hardware that would have been tested. Anyways, you get to this level of abstraction at some point. So I'm going to read this article because Goliath has really good documentation.
Okay. And so that's something that folks might be able to learn a little bit more.
I think
just from the newsletter, where would they see this in the Adafruit world? If it works out.
If it works out, you know what you might see is, especially Adafruit.io, like you'll see this on the back end as we're doing the Whippersnapper firmware, which is public. You'll see the continuous integration running this. And also, what might happen is if people are having issues with Adafruit.io, we might ask them, "Hey, can you try this PyTest code on your hardware?" Especially if they're running like Python hardware, and say like, can you pip install PyTest and then run this PyTest suite, and they will use the real hardware, but tell us like where did it fail. Better than just saying like it doesn't work. Like we'll actually get like a proper report.
Okay. And that's this week's Python on hardware.
Yep.
Again, don't forget it's on adafruitdaily.com. Okay. Let's do some open source hardware news and more. So the first thing we're going to do is show a video. You want to talk about this before I show this is a video from Jepler?
No, show the video.
Show the video?
Yeah.
Let the video speak for itself.
Yes.
Hi, Jeff here. Progress and change in software is kind of inevitable. Espressif is preparing a new version of their board support package for ESP32 family microcontrollers like the ESP32S3 on this Matrix Portal board. This required a few changes in the Matrix Portal library, and I'm happy to say that I got it working. Here you can see it running the Pixel Dust demo, which, if you've never tried it before, it's really satisfying to play with. These changes are in the latest version of the Adafruit Protomatter library for Arduino. No updates to existing sketches are needed, so all the existing guides and examples continue to work. And that's what's going on today.
Okay, and back to open source hardware news. We have a ton of guides and files that we publish. Over 3,000 altogether. Let's go to what's on the big board this week. Lady Ada.
Okay. We've got 2 new guides for the analog matrix switches that went in the store like 2 weeks ago. Thanks to Liz to porting my Arduino code to CircuitPython and then writing these up. These are dual 1 to 4 switches or 1 to 8 matrix switches. Good if you have analog signals between 0 and 5 volts and you want to like switch them around or move them. Maybe for some synthesizer stuff. Or some analog digital readings. If you only have like one ADC, but you want to have multiple switched, these will do the job for you. Okay, also got the Pico DVI project that's from Noe Pedro and Liz, taking Adafruit.io feeds, reading them over a Pico W, and then blasting them to this super retro HDMI monitor display can drive any DVI monitor. In this case, I have a small desktop one, but it can drive like a gigantic monitor too. It'll always work. Liz also wrote a quick guide for the infrared remote receiver. This is like a nice multi-angular remote receiver for adding IR remote controlled projects without having to like have the little plug-in version of the sensor. And also it's got a little indicator signal to let you know something worked, and you can select which sensor you want to read data from. So it's got mounting holes. So it's kind of a nice glow up for your standard IR sensor. And then if you scroll down a little bit, Melissa's also been doing a huge sweep of all of our Raspberry Pi projects, especially ones that might have issue with Bookworm and the Pi 5, and just verifying that they all still work or fixing them up so that they work with the Pi 5. So you'll see lots more updated Raspberry Pi projects. If you are running Bookworm or Raspberry Pi 5 and one of our guys doesn't work, just leave a feedback and we will add it to our list and hopefully get to it and fix it.
Okay, that's learn.adafruit.com. And then if you check it out, we also have some things on Playgrounds where you can post your own guides.
Yes, this is cool. I love the calculators. Jepler, I think, did a calculating project a long time ago for the Pi Portal. It's been a long time. But this is a kind of a remix from C. Grover. It's a CG35. So it's like our RPN calculator based off of the HP35, the classic. And using udecimal means you get like better than floating point precision because you have like, decimal number precision. And just check it out. I love that. Like, this is a great example of something that's good for Playground. It's user project. It wouldn't necessarily make a good guide, but like instead of us having to edit it and go back and forth, they're free to just publish it on Playground and share it with the rest of the community.
All right. You can check that out. Go to learn.adafruit.com and then you can just click Playgrounds from there.
Yep.
All right, let's do some main New York City factory footage. And 3D printing time. We're going to play these back to back. This is the IoT project that we had on Show and Tell. And Lydia was talking about on the Learn section, the open source hardware section, and then we're going to do a speed up takeaway.
You can display Adafruit I/O data on any HDMI display with the Raspberry Pi Pico W and Adafruit's Pi Cowbell DVI output. This Pi Cowbell add-on board is designed to work with the Raspberry Pi Pico W and lets you display images and graphics to any HDMI display or TV. The Adafruit Proto Pi Cowbell doubler puts the Pico and an add-on board side by side with additional ports, pinouts, and LiPo battery charging. We designed and 3D printed a mounting plate to house the Proto doubler. We secured it to the back of our 7-inch HDMI display, which has VESA-compatible mounting holes. A SCD41 CO2 and humidity sensor are set up to log data to an Adafruit I/O feed. We also have a DS18B20 waterproof sensor logging our pool's temperature. Using our Pico DVI I/O project, we're able to display data from both of our sensor nodes on our HDMI monitor. We think this is a great way to display sensor data to any HDMI TV, especially for workshops or educational office spaces. The code uses the Pico DVI library for Arduino to display images and graphics. Adafruit I/O now features hardware support for the Raspberry Pi Pico W. To learn more about this project, check out the tutorial on learn.adafruit.com. You can get the parts to build this project from the Adafruit shop, links are in the description. These DIY HDMI connectors and ribbon cables are great for these type of projects. You can 3D print the mounting plate in your favorite PLA filament. The mounting plate features built-in standoffs for securing the Adafruit Proto Pi Cowbell doubler with machine screws. Additional standoffs are used to secure a top cover that features mounting slots for additional sensors and components. We hope this inspires you to try Adafruit I/O and the Pico DVI for your next IoT project.
don't forget the code is BillCam. Let's do some Eye on MPI.
Eye on MPI.
Eye on MPI brought to you by DigiKey and Adafruit. Thanks, DigiKey. This week it is from ISSI.
Yeah.
What is the new product introduction of the week this week?
Okay, ISSI. I love their LED driver chips, but they're also famous for their flash memory. And this week we're going to talk about memory. In this particular case, we're talking about PSRAM chips because DigiKey.com highlighted their serial and parallel memory chips. And what caught my eye in particular was their 8 SOIC package, QSPI/SPI. PSRAM available in 1.8 volt or 3 volt, 3.3 volt. Logic and power, 100 megahertz speed, with burst output, available in a couple different packages. But basically, perfectly designed for chips that can take advantage of PSRAM, which is more and more chips these days. If you remember back in the day, the Atmega 328 was like an amazing chip. This chip came with 8-bit processor, 32 kilobytes of flash, 2 kilobytes of SRAM. That was amazing. We loved it. It was so spacious compared to the 32 bytes or 64 bytes we were used to. But that isn't even really enough anymore these days. We need more memory, more flash, more RAM. And one of the issues with chips, I thought this die shot was great because you can see it's not a RAM bank. I think it's the cache on the side, but you can imagine it's a RAM bank or a flash bank on the side. When you buy chips, you're buying pins and you're buying processor speed. Like your Cortex M0 is going to be less expensive than an M4, which is less expensive than an M7. But the more processor speed, the more you pay, the more pins, the more you pay, and the more flash and the more RAM you pay. The problem with flash and RAM is that, if it's built into the chip, like here, this is an RP2040, it takes up a significant amount of space. And so chip manufacturers want to optimize the amount of space used because you pay for the die size. They don't want to include more SRAM or flash memory than they can get away with. Kind of the less they can get away with, the better, because they have a smaller die. They don't have to, they get more chips per wafer. Their yield is better, et cetera, et cetera. So for example, one thing we've noticed lately with chips, especially the RP2040 is for a lot of people, the first microcontroller that does this. There is no flash memory on the chip. There's SRAM, but there's no flash memory because you're expected to attach the flash memory using a QSPI chip like this one. ISSI also makes tons of them. The SL25 series. You connect up to the QSPI port on like the RP2040, and then you can pick any size flash chip from as little as 512K up to 16 megabytes, which is a lot. And you pay a little bit more for more memory, and you do need more board space. But the RP2040 doesn't have to come in like 15 different versions. Like the Atmega has like different sizes for every chip because you might want more RAM or less RAM, and you have to pay for it. So you have like this wide range of chips. With the RP2040, they're like, no, we're only going to make one chip, and you choose how much flash you want. And then, likewise, a lot of microprocessors historically, you'd have an external flash chip, but you'd also have an external RAM chip. Like, for example, you'd have sort of like a parallel DRAM. So I remember taking apart, my, Palm 3, and it had, I think, like a Motorola Coldfire chip. And there was, flash memory. And then there was the DRAM, which was, kind of looked like this. It was a TSOP chip. It probably had like, maybe 1 megabyte of DRAM. But the problem is that these DRAM chips, even though they're really popular and they're used in, embedded Linux and embedded processors, ARM, the ARM7 series, TDMI series, and higher, is you need a lot of GPIO because they often have, 8 to 12 address pins, and then they have like 8, 16, or even 32 data pins. So these are for processors that are like BGA and have, 168, 144 GPIO. So it's no big deal if a quarter of them are lost to the DRAM interface, and you also want very, very fast RAM. But for chips that are smaller, like for example, like this ESP32, only has 44, 56, maybe 64 GPIO. You can't have 32 pins for the SRAM and for the flash memory. So like the RP2040, the ESP32 doesn't have built-in flash, or it has very little, maybe it has some ROM. It has some onboard SRAM, but only like 300K. And if you want to use, you know, the ESP32 series to read large buffers or use TLS, so you're encrypting stuff, you're going to quickly run out of memory with that 320 kilobytes. You really need like a megabyte or two to read images from a camera, to buffer a display, to hold fonts, to hold, you know, like I said, JSON data for posting to or from, internet connectivity or protobufs or whatever. You know, if you're going to do these kind of IoT projects, you're going to need PSRAM. And so more chips like the ESP32 and also the IMX series also supports PSRAM. There's a data sheet here where you tell it basically, you know, these 6 pins are connected to external QSPI RAM, and I want you to read it on boot and then integrate it into the program. And so the program sees it as like a contiguous chunk of memory. It's slower than the onboard SRAM, but again, you want to, like, let's say you have your TNC 4.1, you want to buffer a gigantic waveform because you're making some cool synth project. You need a couple kilobytes for each waveform before you know it. You know, you want maybe 32-bit resolution. You're going to use a lot of memory. You need a 1 megabyte of PSRAM, and you can solder it on the bottom. You can see on the left there's 2 spots, one for flash memory and one for PSRAM if the internal SRAM isn't enough. And the good news is that PSRAM uses kind of a standard interface. So if you have a chip that uses PSRAM, this is the pinout for the ISSI PSRAM, it's good to go. And then you will need to tell your compiler or your tool chain, hey, you know, PSRAM is attached to these pins. And you might have to tell it the command names, especially for like quad IO read and write, or to put it into quad mode. Sometimes there's like a special, the bit for where you set the quad bit is in a certain location. Like you see, it says enter QSPI mode. Sometimes that varies from chip to chip. So you do sometimes have to configure it. So don't be surprised if it's like, oh, I started this chip up and it didn't immediately work. You probably have to like change some setting in the make file. Good news is that like ISI is, you know, very popular, very prolific maker of memory. And so if you have a chip that supports PSRAM, they probably already have a configuration file for ISSI. And they're available in a lot of different sizes and voltage levels. So there's the ALL series that's 1.8, the BLL series that's 3.3, and then various packages and density. You know, I think I looked and DigiKey stocks between 1 megabyte and up to, I think, 16 megabytes of PSRAM. So you can have like huge buffers for, you know, data capture. You know, it's not going to be, you know, one nice thing that's about PSRAM is that, especially if you are doing data capture, you want to grab a lot of information from like a DAC or from an ADC or whatever, is you're not going to have the page erase issue with SPI flash, and you're not going to have the high expense of FRAM. So as long as you're okay with, you know, the memory being erased when the power is lost, which, you know, PSRAM is dynamic, you can have gigantic data buffers for like only about $1 or $2. I would suggest if you're like, which one do I start with? 2 megabytes, 16 megabytes is a good place to go. Check this out. The IS66WVS2 M8BLL can run up to 100 megahertz, nice and fast. 2 megabytes of memory for about $2.
That is this week's INPI. Alrighty, before we get to new products, don't forget the code is BellCam all the way up to 11:59 p.m. Eastern time, and there's a bunch of free stuff. Domestic orders only soon, so keep getting free stuff while you can. If you're international, domestic, you're be fine for now. Okay, let's do new. Basically have a bunch of new products, but they're a bunch of different types. So let's start with these first, and then we'll go off
There's
to
two
like,
variants.
the stars of the show.
People love the NVMe under hat. I don't remember the exact name from Pimoroni. A lot of people made, you know, NVMe PCIe adapters for the Pi 5. I'm glad we didn't have to do it. So Pimoroni did it. We stock them. We just put some in stock actually today. And they also have extra cables if you broke your cable, or if you want extra cables, or if you want extra long cable. There's like the standard shorty cable, and then there's the extra longer cable. So you can have, like, if you want it in an enclosure and then you need a little bit more spacing, you can pick up one of these beautiful S-shaped, you know, impedance matched
Okay.
cables for your
And-
NVMe hat.
And the stars of the show, besides you, Lady Ada, team, our customers, our community, is a bunch of these Pico bells.
Camera bells. Okay, so Pi cowbells to add camera and SD cards. So there's like 5 different products, but I'm just going to talk about like one.
Yeah, I
and
have
then
the example.
we'll show the example.
Yeah, so we'll do that. So
We'll do that.
We'll start with this, and then we'll
Okay.
do this, and I'll do this. So let's start with this.
So actually, can you go to here because the top down?
I'll start with this.
Yeah. Okay. So this is a Pi cowbell, which means it plugs in next to or on top of a Raspberry Pi Pico or Pico W, and lets you connect a parallel, otherwise known as a DVP camera. These are digital video cameras that have a parallel interface. So you need to take advantage of the PIO interface on the Raspberry Pi Pico, but it works quite well. And it can quickly grab all the data from the camera and store it either to an SD card or keep it in memory. In the center there is the camera module, and there's like a standard pinout. It's like a 24 pin pinout. So there's different camera modules, different lenses. They all have the OV5640 camera sensor, which I find to be like the nicest one. Some people like the 2640. Lower resolution, I found not as high quality. I really like the 5640. And then I also have on the left, there's a little shutter button, pin 22. You can press it to take a photo or whatever. It's just like an extra button. A STEMMA QT port for adding sensors or whatever. In the middle is that camera sensor. You see the lens. Above it is a reset button, so you can reset the board. To the left, kind of in the middle there is all of the circuitry for supporting the camera. And on the right is a micro SD socket, so you can take images and then save them. So you can make a little mini camera. The only thing is there's no preview screen. If you want a preview screen, you'd wire it up like this. We'll show the pinouts. And then, you can have live stream video image from the camera come to the TFT, so to show you a preview. And then you can also take photos and save them, like I said, to the micro SD card. So these come in a variety of different lenses, and each lens has like its pros and cons. So the first lens is like the biggest. It's the 160 degrees. So this is very, very wide angle. So if you see the photo, like the figurine in the center is very small, and you see like a very wide image, like a 160-degree image of the background, but it's kind of distorted. Like you see things are sort of at the edges, they're curved because it's got a distorting lens because it's such a, it's like a fisheye lens. We also have this is 120 degrees, so this is also a little bit wide, but it's a non-distorting. So if you look at the image, it is wide, but you see the lines are like mostly straight. It's a low distortion lens, but it doesn't have autofocus. We also have a 120 lens that does have some distortion. It's a little bit less expensive. You kind of, pay a little bit more. So you see this, it's got a little bit of a wide angle, like zoom in effect as well. There's also a 120 degree with autofocus. So that metal body around the lens is the autofocus circuitry. It uses a lot of power because there's a little motor coil inside that can move the lens up and down, and you have to load, this firmware into the camera over I2C. It takes like a second or two, and then you can tell it to do autofocus, and it kind of works pretty well. And this is what that camera looks like. It's a slightly different image. And then finally, we have a 72 degree, which is a non-fisheye. Like that's kind of when you think of one-to-one camera images, this is it. And it also has the autofocus. You can see like everything is exactly as you would imagine is if you see it with your eye. It's like non-distorted at all. You will use the narrow lens if you're just wanting to take everyday photos of people and things. The wide angle lenses are for like if you're doing like some time lapses, or you want to take a photo of like a backyard and you want to get the entire backyard, not just a narrow part of it. Because again, it's not motorized, like there's no pan, tilt, zoom, and so you can't move back and forth. So you just have like a really wide lens, and then even though it's distorted, a lot of people when they make like a security camera or monitoring or a time lapse camera, they'll use a wide angle lens. That said, the code is the same for all of them. It's just like the lens is a little bit different. And so we've got code for the Pico and Pico W. These aren't in the store yet, so you can sign up. I have to finish the tester. It'll be in next week. It's only for CircuitPython right now. I don't believe we have code in Arduino for the camera, although I think some people have written some SDK C++ code for the Pico to interface with these camera modules. And like I said, you know, the camera module is kind of generic. You know, you sort of set it up, you send all these registers, and then it just sort of streams data out in either raw RGB mode, or you can put it into JPEG mode, which is great for snapping a photo. It's compressed, and then you can save it directly to the SD card.
All right. And with that, with all these cameras this week, that is new products.
Thank you.
Okay. So what we're going to do is we have some questions lined up. Post them over on Discord, adafruit.it/Discord. We're going to answer them, but first we're going to do some top secret. So let the videos play. Okay, Lady Ada, what is this?
This is a new Cutie Pie board, and this is a pretty cool chip because this isn't an ABR, and it's not a SAMD, and it's not an RP2040. It's an 8051. Yeah, they're still making those. This is a CH552P, and if you look on my computer, there is an Arduino core written by Deshing for it. And I have here one doing a little NeoPixel demo. It totally works. There's like 4 analog inputs, digital I/O, SPI, I2C. The only thing is, it's not a C++ compiler, it's a C compiler. And so like you can't use our libraries and demo code with it, but there is some example code for just like, bit banging NeoPixels, for example, as you see here, reading the analog input, doing some GPIO, and it does have a native USB interface that you can use with HID or CDC, which is kind of cool because it's an 8051. It's like famous for being like 25 cents or something, a very inexpensive chip. So it's not going to run CircuitPython, and it kind of barely runs Arduino code. But it's pretty cool, an 8051 Cutie Pie. So I thought, maybe for the hackers, it'll be a good one. Want to experiment with an 8051.
All right, Lady Ada, what's this?
These are flying toasters, but these are flying toasters generated by a sock. I'm holding this like kind of non-solder style, just kind of press fitting it. But this is what we call a DVI sock. It's based off of a design by the Raspberry Pi Foundation for Pico boards, and it fits on the bottom like this. Like normally you would solder it in place, and it kind of extends out and gives you a DVI output that you can then use to display up to, well, with our code, 640 by 480 full color, which is 320 by 240 pixel doubled, but still pretty nice, great for little retro projects. And of course you get a full frame buffer. And then, it's just bit banging over PIO, the 3 lanes of data plus clock. You get some resistors in line, and then, your DVI connector. You could use an HDMI monitor, some capacitors, and then pinouts for the hot plug detect, CEC, util, and 5-volt ground. So this should make it really easy if you want to really quickly get a DVI or HDMI compatible project going on your Pico or Pico W without having to have a full DVI Pico bell. So coming soon.
That's top secret.
Yeah, that's secret stuff, not quite ready for the shop. But coming soon.
Yeah.
People like the 8051 stuff.
We're going to jump right to the questions. Yeah, we've been trying to end a little earlier because we have to put a kid to bed.
Yeah.
So, getting to all the important stuff though. Okay, so I'm gonna, I got the questions lined up. I'll start with the new product ones. Does the camera use 1 or 2 PIOs?
I believe it uses only 1 because we don't have to generate the clock. I believe it's only 1 PIO.
All right, JP mentions over-the-air CircuitPython updates for his controller project. Is this web workflow, and is that available for the Memento ESP32S3?
We do have web workflow for the S3. I believe Melissa wrote a guide about using it. But over-the-air, I think his controller is an Arduino, not CircuitPython. And so the over-the-air, the updates is the Arduino over-the-air code.
Okay, a couple of weeks ago, you mentioned the unfun. Any chance of Adafruit carrying it?
I don't remember what it is.
Is that the Pimeroni thing? They did in
right.
They did in
right.
partnership
I
with
think
University of
it's a
Sheffield.
special partnership. I don't know if it's available for us to purchase.
We'll check it out.
But you can buy it directly from them.
Yeah.
For sure.
Adafruit Cowbell cam question. Do they do video? If not, is there an Adafruit cam that's good for video? I need a live video synthesizer 7-inch screen to show on a TV. Thank you. Always prefer an Adafruit solution.
Really a Raspberry Pi is the best thing for that because it's got HDMI output and it's got like really good camera input. It can do both at the same time. The Pico can't do DVI and camera at the same time. That definitely doesn't have enough memory for it. You'll just be sad. So yeah, definitely just get like a Pi Camera 2 and a, Raspberry Pi 4, I think would do a plenty good job. I think a Pi Zero might not be fast enough to do the kind of camera video synthesizer stuff you'll get frustrated again, but a Pi 4 can do it.
Okay, and what's the easiest way to, you alluded to that before, what's the easiest way to wire up one of these to show video? Are we gonna have a guide or something?
Yeah, we're gonna have a guide. It's not, it's not live in the shop yet.
Okay.
It's not, you can do a live preview on a TFT, but it's not a video. It's like a couple frames per second.
So it's a preview, not video.
It's a preview, not video. I mean, it's video in the sense that it's moving images, but the images are not 60 frames per second.
Okay. So if you want to do something like
It's like
this.
5 or 10 frames per second. Yeah, this is just to like demonstrate the lenses. I wanted to show like here's the lenses look like. Yeah.
Okay. Let me see if there's any more questions that came in. I think we did it. I said I would try to get you up by 8:45 tonight, and I think we did.
Great.
All right, everybody.
We chose it an hour and a half, so this is where I'm taking it back from the bank because
we're trying to.
You gotta get this baby to sleep.
We're trying to get kids to sleep before 9. Okay, so let's bounce. We'll see everybody next week. Don't forget everybody. The code is Belcam. This has been an Adafruit production.
Thanks, everybody.
Here is your moment of Zener.